Every year, antibiotics save millions of lives worldwide, but it all started with one incredible discovery. Before this discovery, a simple infection could be deadly. That was the reality until the discovery of penicillin, the antibiotic that revolutionized medicine. How did a mold change the world? Let's dive into the story of penicillin and its life-saving impact. It all began in 1928, when British scientist Alexander Fleming made a discovery that would change medicine forever. Fleming returned from a 2-week vacation to find a petri dish containing Staphylococcus bacteria. What caught his attention was an area surrounding the mold where no bacteria was growing. Fleming quickly realized that the mold was producing a substance capable of killing bacteria. That mold was identified as Penicillium notatum, and the substance it produced was later named penicillin. Though Fleming is credited with discovering penicillin, unlocking its full potential was a challenging journey. He struggled to extract the compound in sufficient quantities and had difficulty finding practical ways to mass-produce it. Years later, in the early 1940s, scientists Howard Florey and Ernst, along with their team at the University of Oxford, took up the challenge. They successfully purified penicillin and developed a method for large-scale production. Their work proved crucial during World War II, saving countless lives by treating bacterial infections in wounded soldiers and drastically reducing mortality rates. The scientific and medical communities quickly recognized penicillin's significance. It became the first antibiotic capable of effectively treating a broad range of bacterial infections, leading to its mass production and saving countless lives. To understand penicillin, we need to examine its chemical structure. Penicillin belongs to a class of antibiotics called beta-lactams, as it contains a beta-lactam ring, a 4-membered structure essential for its antibacterial effect. This ring is crucial because it disrupts bacterial cell wall synthesis. Bacteria rely on a strong cell wall for structure and protection. This wall is made of a polymer called peptidoglycan, which helps bacteria maintain their shape and withstand environmental stress. Penicillin works by interfering with the enzymes that build the peptidoglycan layer of the bacterial cell wall. When penicillin binds to these enzymes, it prevents them from forming the peptidoglycan structure, weakening the cell wall, leading to their death as they continue to grow and divide. Penicillin is especially effective against gram-positive bacteria, which have thick, rigid cell walls. However, it has limited effectiveness against gram-negative bacteria, which have more complex and protective outer membranes and often require different types of antibiotics. Penicillin revolutionized medicine. Before antibiotics, bacterial infections were often fatal. Simple conditions like pneumonia, ear infections, or even minor cuts could lead to sepsis, a life-threatening condition. The discovery of penicillin transformed healthcare. By the 1940s and 1950s, antibiotics became a cornerstone of modern medicine, drastically reducing mortality rates and making once deadly diseases treatable. Beyond treating infections, penicillin also allowed for safer surgeries. Before antibiotics, even routine procedures carried high risks of infection. With the ability to prevent and treat infections, doctors could perform more complex surgeries with greater success. While it saved millions of lives, its widespread use has led to significant challenges. One of the biggest problems is antibiotic resistance. Over time, some bacteria have evolved mechanisms to survive antibiotics, making certain infections harder to treat. With one of the most well-known examples being penicillin-resistant Staphylococcus aureus. Some bacteria develop resistance by producing an enzyme called beta-lactamase, which breaks down the beta-lactam ring in penicillin, rendering it ineffective. Others modify their cell wall structure or target enzymes, making it harder for penicillin to work. Antibiotic resistance is a growing public health threat. Penicillin's discovery was nothing short of revolutionary. From a humble mold on a petri dish to one of the most important drugs in medical history, it changed the world. It saved millions of lives, and its impact on medicine is still felt today. So, the next time you take an antibiotic, remember the groundbreaking discovery that made it possible and the scientists who turned a lucky accident into a life-saving breakthrough. As always, thank you for watching, and we'll see you in the next video.